Functions of random variables. Again, I went over this in more detail in the Math Camp lesson. You might want to review that. I'm just going to hit the high points here. First point is, what do we mean when we take a function of a random variable? It means that we apply the function to the outcomes. Okay, so if we have random variable x that takes outcomes x1 and x2 with probability p1 and p2, and we want to apply a function like squaring, we want to square random variable x, what that means is we square each possible outcome and leave the probabilities the same. So that's one point. Applying a function means you're applying the function to the outcomes and the probabilities are unchanged. And that sort of makes sense, right? If random variable x takes value x1 with probability p1, it makes sense that x squared should take the square of x1 with that same probability. Okay? And saying something that's a function of a random variable, it means that that function is itself a random variable whose outcome is determined by the first random variable. Okay, so x comes up x1, x2 comes up the square of that, x comes up x2, x2 comes up the square of that. Okay. The most important point about functions of random variables is we can't necessarily switch the order of taking a function and doing the expected value. Okay, so the last rest here. In general, the expectation of f of x does not equal the function applied to the expected value. Okay. So again, looking at this one, the expected value of random variable x squared is not the same thing as the square of the expected value of x. Okay, and maybe let's put some numbers in here just to emphasize that. Okay, so if we start with random variable x, say it takes value 3 with probability 1/2 and 0 with probability 1/2. Okay, fine. Expected value of x is 3/2. That one I can do in my head. X squared, then if x is 3, then x squared is 9. And if x comes up 0, x squared comes up 0. So the expected value of the new random variable x squared is 9/2. That is a different number than if I just took the expected value of x and squared it. Okay, that would be 9/4. So it matters whether you take the expected value first. Actually, taking the expected value first would put it inside the parentheses. Take the expected value, get a number, and plug that into the function. That'll give you one number that's not necessarily the same thing as applying the function to the random variable and then taking its expected value. Okay? So the punchline here of this little example is that the expectation of x squared, okay, so I'm doing the expected value first and then squaring that. That is not the same thing as squaring the random variable and then taking its expected value. So that's one illustration, and really the most important illustration of this general rule. But there is an exception. Okay, so the fact that we normally can't do it is really, really important. We're going to have to remember that in the coming lessons. It's going to be critical. But we're also going to need to remember that there's one situation in which we can switch the order, and that is for a linear function. Okay, so I'll switch colors here for my linear function. Okay, so there is except for this case. Okay, if what we're doing to the random variable is multiplying it by a number and adding another number to it. Okay, then we get the same answer when we take its expected value as if we took the expected value of the original variable, multiplied it by that same a, and added b. So let's look at that with our 3,0 example here, just copying it down. X can be 3,0, probability of X, 1/2. And let's just keep the letters A and B here. Okay, if I apply the ax plus b function here, if x is 3, then I get 3a plus b. If x is 0, then I get a times 0 plus b, I just get b. So just as before, ex is 3/2. Let's calculate the expected value now of this new one here. Okay, this a times x plus b. Expected value of a. Okay, well, with probability 1/2, it's 3a plus b, and with probability 1/2, it's b. Okay, so that is 3/2 a plus 1/2 b plus 1/2 b. It is 3/2 a plus b, which is indeed the same thing that we get if we take the expected value and multiply it by a and add b. Okay, so what we've got here is applying the function first, then taking the expected value. And what we've got over here is, or what we don't have over here, but what I'm going to get ready to write is a times the expected value of x plus b is a times 3/2 plus b. Okay, so for this particular type of function, this linear function, we can switch the order of expectation and applying the function, and that turns out to be hugely helpful. It is also beyond helpful. It is critical to remember that for other functions, we can't switch the order. Okay. Again, take a look at lesson 2A from Math Camp. If you aren't quite sure like why these things are true, there's more details there. You might want to work through the little workshop problem that was associated with that. That will help you as well. We're going to go on and be using both of these facts to talk about variance. So when we have random variables, probably the most important thing we want to know is what's their expected value, but the second most important thing is usually what their variance is. So I'll see you in the next lesson.